does the notion of the tangent to the grade sitting okay? If you know the grade, you can then use a tangent table. Use any one you want. Google it. They're all right. At least the first page worth is right. I've checked them in the past. Look at the grade, find the grade in the tangent, and then look to the left. That tells you the angle that you're forming. Okay? So looking around Bend, anybody recognize this road? In Bend, it's on the north side. That is Archie Briggs. This was my old commute. I knocked him up through here. Sucks.
It does. It really
Sucks. Why does it suck?
Because the angle's horrible.
What is that? What angle is formed right there? This is the steepest part of Archie Briggs. Steepest part of Archie Briggs right here. This is the hairpin. So the Deschutes is right around the corner. You drop into the canyon, cross the Deschutes. The Deschutes River Trail comes right in there, crosses, and then crosses across the road. Then you start climbing back up the butte. Michelle, go ahead.
Right before that sign, I actually slid all the way down to that guy's driveway.
I believe it.
Turned around and said,
This is a north-facing road. When it gets covered in snow and then melts out and refreezes, it's one of the most treacherous roads in town. I've actually, when I bike up it in the winter, it's hilarious. I see semis back there. They get stuck on this road, and I just pedal around them like, guys, should have gone the other way. Go ahead, Karen.
How do you figure out how fast you can take the corners?
And it depends on a lot of factors. How good are your tires?
Weight of your car.
How good are your tires, right? If you got sticky enough tires, you can lean way, way. You see those guys that race a motorcycle, they're leaned over at like 45 degrees, and they're hitting, 100 miles an hour. It depends on how much you trust. The biggest problem I have with this road is there are always cinders on this turn. That's my problem. I have great tires on my bike. I don't trust the road. So I come in, I hit this at 30 almost all the time. Mentally, I cannot go any faster than 30. I just won't let myself go faster. I'm like, if I go any faster, I'm going to end up in that guy's driveway with a broken 2 shoulders. So, but the question, how steep is it? Guesses. Or give me a grade. Give me a grade. How does it compare to College Way? Those of you who know it. College Way is 6%.
8 or 9.
8 or 9. 8 or 9. Okay, now talk about just the switchback right that I'm showing you. 8 or 9? Which would correspond to a different angle, slightly steeper angle. We can grab that too. At that steepest part, it's 16.7%. At that steepest part, if you've ever tried to ride your bike up Archie Briggs, that's when your heart rate kicks. There's a series of mailboxes right up here. There's a bike race in Bend every year, the Cascade Cycling Classic. They do this, I think, 6 times. They do a loop including this thing 6 times. I always stand at the mailbox and I cheer them on and I hand them beer at the 6th lap. Because they deserve it by that point. They deserve it by that point, if they're not winning. Just finish the damn race. Get your time in. It's insane. And then it levels off, and then it kicks back up and it levels off again. 16.7%, let's exit out of here real quick, go back to our tangent table. 16.7%, where would I look that up again? Which column, degree or tan? Tan. So get as close as you can to 16.7. Somewhere between here, between 9 and 10. So 9.5 degrees. Which is, you think to yourself, it's 3 times more degrees than College Way is, ish. You have to crank the degree up. Now, and then again, that doesn't seem, if you think about 9 degrees, it's 1/10 of 90, which doesn't seem like all that much. But I encourage you, take your bike out there. Seriously, if you get a chance, and then be careful coming back down. All right, let's move around again. Move around Bend a little bit more. So there's Archie Briggs. And recognize this one. I like this one. It illustrates an interesting point of grade.
Isn't that the one that's right over here?
It is right over here.
Juniper.
It's Juniper. It's the one parallel to College Way. It's parallel to College Way. It's 1 block east of College Way. So College Way is the next road over this way. That, I believe, is Portland right there. I think. I could be wrong. It might be Ogden or whatever the hell roads. It doesn't matter. But essentially, here's what happens. I'm going to slide this up. College Way and Portland. College Way and Portland cover the same rise in the same run, but they do it differently. And that's what I love about Juniper. I just said College Way and Portland. College Way and Juniper cover the same rise in the same run. So we know that College Way, so I guess I'll give you the answer already, it's 17.7% right here. This section of Juniper, which looks like a brick wall when you're riding at it. This section of Juniper, which is halfway, here's Newport back here, this is relatively flat, almost perfectly flat. Then it rears up and it looks like a brick wall when you're riding towards it. Then you get up on it and you're like, okay, it's not a brick wall, but my heart rate's racing. So Juniper does this. Okay? Does that. I'm exaggerating the difference there. So, if I just told you that juniper is 17.7%,
Take it.
that means this thing rises 17.7 feet for every 100 feet here. That's 17.7%, yes? That section of juniper, 17.7%. Stay there, okay. Everybody following so far? That's just that part, that block of juniper though. Very, very scary to ride on a bike because it's usually covered in dust and grime and all kinds of crap. And the road above it is not even paved very well.
Yeah.
But here's the deal. If you take it back to here and you draw a line from here to here, that is only 6%. That's only 6%. Now how can that be? How can that be? How can it be that it's only 6% if you go... Now, I haven't drawn any of this to scale, but how can it be that if you start tracking... This is Newport back here. If you turn it at Newport, and if the road existed that went from here to here, which it doesn't. Actually, it does. One block over, it's called College Way, which essentially does that. But if on Juniper you could float through the air to the top of Portland, it would be a 6% grade. I've never measured that. I can't measure that because it doesn't exist. So how do I know it? How do I know it? Go ahead, Michelle, what's on your mind back there?
Because it's more of an ease into the top. It's not
Right.
straight up.
So in other words, how far is this? How far is this? How far is that distance? I haven't drawn it to scale. It looks like it's about 300 feet. I didn't try to make it to scale. So if this green triangle here represents a 6% grade, and the red one in there is 17.7%, can you figure out how to solve for how far this overriding run is right here? How could we figure that out? How could we figure that out? So I'm going to draw a couple separate pictures, okay? Let's go with you guys. We know this triangle right here. This is the big green triangle there. This is a 6% grade. Big green one, 6% grade. The little red one in here is a 17.7% grade. Using the two pieces of information, can we figure out what that is right there? How? This is why we had linear equation boot camp, FYI. Tell me your name. Say again. Will, go, help me.
17.7 over x equals 6 over
Let's think about this. We know this is a 6% grade, correct? So we know the grade of this thing is 0.06, and that's equal to the rise over the run. First principles. There's an idea in mathematics and science called first principles. When in doubt, go back to the most basic first thing you learned about a topic. Grade, rise over run. Boom. Rise over run, yes? So we know it's a 6% grade. Rise over run. Two variables, can't solve for it. Except don't you know the rise? The rise is the same rise in the short triangle. This part of the road is flat. There is no rise there. Does that make sense? Hopefully it does. Well, I just told you. Hopefully believe me. Zero rise, all 17.7 feet happen right here. So you pick up the 17.7 feet right here, 0.06. The run is what we're looking for. Can we solve for that? Hell yeah, we can! This is why we had linear equation boot camp. How do you solve for that question mark that's right there? How do you solve? And now there's a bunch of you did it a bunch of different ways. Some of you like cross multiplication, totally fine, not gonna tell you not to. But the obvious thing is you have to get the question mark over to this side. Yes? Maybe believe me. Maybe go on, please.
Wouldn't you want the 17.7 into the same thing as the 0.06 though?
Yes, you want to have these two get together and kick him over to the side. The question is how to do it legally.
Well, wouldn't you just convert that to 0.177? Because if you put this,
One. Oh, but it's 17.7 feet. I can't convert it. If you can convert it to some other form of measurement,
I
but
thought it was
this is going to have have a unit. This is going to have a foot measurement on it. Does that make sense?
Yeah.
This is going to have a unit on it. So this guy over here is unit less, but that means this guy has to have a unit. He's going to have feet as a unit. Carrie, what's on your mind?
Well, I mean, just following, if I'm correct, the Lego,
Yes.
the Lego.
Yes.
Wouldn't you just start by multiplying each side by 17.7?
If you did that, you'd square this 17.7.
Okay.
Legos would say, how'd the question mark get there?
Okay.
If it starts up high, it has to get reciprocated and then multiplied by that 17.7. So to get rid of it, go ahead, Grant, right?
You said you need the question, which you're looking for, question mark by itself, and you just subtract 7.7.
So if, I heard two things, I'm going to go one at a time. If you multiply by the question mark, which is the variable, I hope you don't mind I'm using a variable in this case. That's going to get rid of the variable over here and put it over here. I heard that first, Grant. That was your idea. I loved it. Now you've got this 0.06 on this side that needs to go over there. Which means we have to divide by it, and you get 17.7 feet divided by 0.06. Whatever that equals is how long that road is.
About 300 feet.
About 300 feet. About 300 feet. Thank you. Thank you, Randall, for the 300 feet. About 300 feet. Which means this guy here is about twice as long as that guy there.
Go through that last part again.
Which last part?
What you just said.
About it being about 300 feet?
The bottom, whole bottom part there. You got the.
So, hey, I want to start at the top. Kelly, tell me where to stop and start explaining.
Keep going, keep going, keep going. Right there.
There.
Oh, here.
Yep.
How did I get from here to here?
Yep.
Is that fair?
Yep.
So, this is what I'm looking for times 0.06. I don't want it times 0.06, I just want what I'm looking for. So using Lego, like Carrie's talking about, I've got to get rid of 0.06 using Lego methods. If it's being multiplied, it must be divided to get rid of it. So I divide this side by 0.06, leaving question mark. I got to divide this side by 0.06 as well. Just inverse operations. Inverse operations.
So you divide that by 0.06.
And then I'll trust in Randall's math. When you divide 17.7 by 0.06, you get about 300.
295.
295. I can live with 300 or 295. Tell me your name.
Chloe,
Chloe, go.
so what I don't understand is why it's 17.7% grade and 17.7
Feet,
feet.
because I chose to put 100 feet right here.
Oh.
17.7 over 100 is 17.7%. If, Chloe, we could make this 35.4 and then make that 200, which would also be 17.7%. Doesn't matter as long as the ratio is 0.177. That's what 17.7% means. Is that fair?
Yeah.
Fair enough. And it's your choice, really. If I just tell you the grade is 17.7%, unless you go out and take measurements, you don't even know what those rises and runs are. With a measurement, you could. I didn't give you the measurements, though. I decided not to. Keep it fairly simple. Chloe, is that okay?
Yeah.
Okay, good. Good question. Tammy, go ahead.
So if you say that it's 17.7%, you can always assume, the easiest way to assume
Yep,
anything
that
is
number
put
over
it-
100.
Put it over 100,
Percent.
and then you just look at the tangent chart.
Then figure out what the angle is,
Figure
yes?
out what the degree, or the, yeah, the.
Damn it, it sounds like you want to. Let's do it. Sounds like you want to. I want to too. 17.7 is damn close to that, isn't it? So, 10 degrees. 10 degrees. Slightly steeper than Archie Briggs. We knew that anyway because it was 17.7 versus 16.7. But check this out. What's cool about that too is, when you go back to the roads, when you go back to Juniper here, that means this angle's 10 degrees. But if you were to draw the line from here back to Newport, that would only be about 3.5 degrees. That's what we learned about College Way, yes? This goes back to Joanne's question I asked you about 20 minutes ago. What's the average angle formed by Pilot Butte? So, right now, we know this angle right here is 10 degrees. The angle back here at Newport, right here, is 0 degrees. The average of the two angles is about 3.5. That's the average grade of the road. Check this out. Check this out. I'm going to mute this down again. Hold that question. Whoever, I saw a hand up. Hold that question for me, friends. So, Chloe, your awesome question. 17.7% is the grade of this section of Juniper Road. 0% is the grade of this section. Hopefully you can see that. It's a 0% grade from here to here, 0%. So the overall average grade from here out to there is the 6%. Because that's the total rise over the total run. That road doesn't exist, correct? That road doesn't exist. That road doesn't exist. But if you connected them with a straight line from bottom to top, it would be a 6% grade. It rises 6 feet for every 100. Now, it doesn't actually do that in reality. The reason I'm bringing this up is this is why you have to be careful when, say, you're fishing in the Deschutes and you're not a very good swimmer and that water's going pretty quickly. And you want to go wade out behind a rock because you think there's some big lunker rainbow out there. Like, I really want to catch this fish. Hey, dude, you ever walk in this river? Yeah, dude, it's like an average 2 foot depth. Oh, I can walk, I'm 6 feet tall. Average of 2 feet doesn't mean anything. There might be a 6 foot hole followed by 2 inches of water that averages out to 2 feet. Averages can be misleading, but average grades are used all the time. All the time. When they tell you there's a 6% downgrade on the road, that doesn't mean it's exactly 6% the whole way. That means it averages to 6% the whole way. There can be sections that are steeper and sections that are shallower. Does that make sense? That's what you just analyzed. This section is 17.7%, this section is 0, the whole thing averages to 6%. Ask yourself this, if you were at Juniper and your friend was at College Way at the same time on your bike, and you both left going northbound on those roads, at the end of those 2 blocks, wouldn't you both be at the same height? You took vastly different routes to get there, but you both covered the same height and you covered the same run. That means you covered the same grade, both 6%.
So is 6% supposed to be like you don't want anything steeper than that? It's an average of if a road averaged like 10%.
Yes.
You
could have sections that are 12 and 13 and 14.
Right.
But also have sections that are 6 and 7 and 5 perhaps. But they average out to, I'm sensing another quiz for next week. This is making me very happy. I'm going to make you guys an average grade quiz for next week. This is good. I love these questions. I wasn't planning on going here, but we're going to go here. This is good. I like this. The road doesn't, Archie Briggs has sections that are slightly downhill. If you go from the river up to the top of Archie Briggs Road at Mount Washington Drive, there are a couple sections where you actually go downhill.
So what's the point of saying there's a 6% grade?
I didn't say there was one. I'm saying it is said. I'm saying it is said all the time. And I'm saying to make sure you know what it means when you read 6% grade. It doesn't promise you it's 6% the entire time. It promises it overall averages to 6%. I'm not saying it's good. I'm not saying it's good. I'm saying it's like Congress. I'm not saying it's good. I'm saying it's there. Okay? It's there and it exists. Go ahead, Terry.
So grade isn't just slope, it's the average of.
It depends. If you're talking about an average grade versus now this is a good question too. This is average grade of this whole region. This 17.7, if you look at that road, it's almost a straight line. So you could talk about average or the exact grade, it's the same thing.
That's like 2 different lines.
Yes, and when you start piecing them together, that's when the average kicks off. So you can extend the definition of grade. Thank you for that question. That was a very good question, thank you. You can extend the definition of grade to include average grade